Introduction. Aditya, what are you doing? I am reading my favorite comic. And what are you doing on laptop? I am doing video chat with my friend. Video chat? What is that? Come here, let me show you. Video chat can be done with the help of internet. It is an application of communication system. In a communication system, there are three major components: sender, communication channel, and receiver. In case of video chat, I am the sender. Internet is the communication channel, and my friend is receiver. Okay, now I understand and I want to know more about this. Students, today we will study more about the communication systems. Objectives. At the end of this lesson, you will be able to know elements of communication system, define basic terminologies, calculate bandwidths of signals, understand about bandwidth of transmission medium, explain the propagation of electromagnetic waves, know modulation and its necessity, define amplitude modulation, analyze the production and detection of amplitude modulated wave. Elements of a communication system. Communication means sending of a message from one place and receiving it at the other place through some mean. A communication system basically contains three elements. Transmitter. The transmitter converts the message signal into a suitable signal which may be passed on to a suitable medium called transmission channel. Transmission channel. It is the medium that carries the message in the form of a suitable signal from one place to another. Every channel involves loss of energy during transmission. Receiver. Receiver converts the suitable signal prepared by transmitter into actual message. Receiver operations include amplification of signal to compensate for the transmission loss, demodulation and decoding to reverse the signal processing performed by the transmitter. Two basic modes of communication. Point-to-point mode. Communication occurs over a link between single transmitter and a receiver. Broadcast mode. Communication takes place over links to a large number of receivers from a single transmitter. Basic terminologies. Transducer. A transducer is a device which converts one form of energy into another. In communication system, it is usually desired to convert a message signal into corresponding variations in the electrical signal at the output of transmitter and then electrical signal into the information signal at the output of receiver. Signal. The information converted into electrical or optical form, whichever is suitable for transmission, is called a signal. The signal may be analog or digital. Noise. The unwanted signal that tends to disturb the transmission and reception of message signals in the communication system is called the noise. Attenuation. The loss of strength of a signal while propagating through a medium is called attenuation. Amplification. The process of increasing the strength of a signal by using an electronic circuit is called amplification. Amplification is necessary to compensate for attenuation of signal in communication channel. Range. It is the largest distance between transmitting and receiving ends up to which the signal has sufficient strength. Bandwidth. Bandwidth is the frequency range of waves occupied by the signal. The bandwidth is different for audio and video signals. Repeater. A repeater is a combination of receiver and a transmitter. Repeaters are used to increase the range of communication of signals. Bandwidths of signals. Bandwidth is a range of frequencies required to convey the information of speech. A signal with zero bandwidth has zero information. More bandwidth is required for signals with more information. A signal has a bandwidth B if it contains a range of frequencies. B is equal to delta F is equal to F2 minus F1, where F2 is the highest and F1 is the lowest significant frequency of the signal. For example, the bandwidth of a telephone speech signal, where B is equal to 3 kHz, with F2 is equal to 3 kHz and F1 is equal to 0. Baseband signals are produced by sources of information. For transmission purposes, the baseband signals are shifted to higher frequencies by the modulation process and are then called the passband signals. Bandwidth of transmission medium. The transmission channels are of three types. Wires. The widely used wire medium is a coaxial cable. The bandwidth of coaxial cables is about 750 MHz. Such cables are usually operated below 18 GHz. Free space. The free space transmission medium communicates radio waves over wide range of frequencies, from a few hundred kHz to a few gigahertz. This frequency range is further subdivided for allocation of various services. Optical fiber. An optical fiber has frequency range 1 THz to 100 THz. It offers a transmission bandwidth more than 100 GHz. Propagation of electromagnetic waves. The Earth's atmosphere presents an exciting range of gaseous layers in which electromagnetic waves of different frequencies propagate in a variety of ways. The electromagnetic waves can be transmitted through three processes: ground wave propagation, space wave propagation, and sky wave propagation. Ground wave propagation. These are the wave radiated by antenna that travel parallel or at lower angles with respect to Earth's surface. As ground wave passes over the surface of Earth, its energy is absorbed by Earth's atmosphere. Therefore, they die out after traveling a short distance. Hence, ground wave propagation can be sustained only at low frequencies, 500 Hz to 1500 kHz. Space wave propagation. The space waves are limited to troposphere region of atmosphere and have two components. Direct waves. These waves travel directly from transmitting to receiving antenna. Reflected waves. These waves travel from transmitting antenna to Earth and then reflected to receiving antenna. Sky wave propagation. These are waves radiated by antenna at large angles, travel upward and then reach the receiving antenna after suffering reflection from ionosphere. The frequency range for sky wave propagation by ionosphere reflection of radio waves is from a few megahertz up to 30 megahertz. The refractive index of ionized layers depends on frequency and given by under root 1 minus 81 upon f square. Example: Let's take an example. A TV tower has a height of 200 meters. How much population is covered by the TV broadcast if the average population density around the tower is 1800 km minus square? Given that the radius of the earth is 6400 kilometers. Let's see the solution. Given values are H is equal to 200 meter. Population density is equal to 1800 per kilometer square. Earth radius is equal to 6400 kilometer. The range of transmission is given by D is equal to under root 2HR. Now, put the values and calculate. We get the value of D is equal to 5.06 into 10 raised to the power 4 meter. Area covered by transmission is equal to pi d square. Population covered is equal to area into population density. Now, put the values and calculate. We get the value 1.447 into 10 raised to the power 7. Hence, 1.447 into 10 raised to the power 7 population is covered by the TV broadcast. Modulation and its necessity. The original low-frequency information signal cannot be transmitted over long distances. Therefore, it is essential to superimpose the information signal in high-frequency radio wave called the carrier wave. The superposition of information signal on high-frequency radio wave is called the modulation. Size of the antenna. For transmitting a signal, we need an antenna. This antenna should have a size comparable to the wavelength of the signal, at least lambda by 4 in dimension, so that the antenna properly senses the time variation of the signal. For an EM wave of frequency 30 kHz, the wavelength lambda is 10 km. It is not possible to construct and operate such a long antenna. Therefore, there is a need of translating the information contained in original low-frequency baseband signal into high frequencies before transmission. Power radiated by an antenna. Power radiated is directly proportional to L upon lambda square. This shows that for the same antenna length, the power radiated increases with increasing frequency. Hence, the effective power radiated by long wavelength baseband signal would be small. For a good transmission, we need high powers, and hence this also points out to the need of using high-frequency transmission. Mixing up of signals from different transmitters. If many transmitters are transmitting baseband information signals simultaneously, then it is difficult to distinguish between them. There is a need for translating the original low-frequency baseband information signal into high-frequency wave before transmission, such that the translated signal continues to possess the information contained in the original signal. A sinusoidal carrier wave can be represented as CT is equal to AC sin omega CT plus phi. There are three types of modulation: amplitude modulation, frequency modulation, and phase modulation. Amplitude modulation. We consider the carrier wave and modulating wave are represented by VCT is equal to VC sin omega CT. VMT is equal to Vm sin omega mt. When a carrier is amplitude modulated, the instantaneous modulating voltage Vm is superimposed onto the carrier amplitude Vc. When the modulation is present, the amplitude of the carrier is varied by its instantaneous value. The modulated carrier wave is given by Vt is equal to Vc plus Vm sin omega mt multiplied by sin omega Ct, which can be written as Vt is equal to Vc sin omega Ct plus mu Vc sin omega mt sin omega Ct, where mu is equal to Vm by Vc is called the modulation index. We can also write the above equation as here Fc minus Fm is called the lower sideband frequency and Fc plus Fm is called the upper sideband frequency. The AM wave thus consists of the carrier wave of frequency Fc and two sinusoidal waves, each with a frequency slightly different from Fc, referred to as sidebands. The bandwidth required for amplitude modulation is twice the frequency of the modulating signal. Production of amplitude modulated wave. Here the modulating signal is added to the carrier signal to produce the signal xt. This signal is passed through a square law device, which is a non-linear device which produces an output given by yt is equal to bxt plus cx square t, where b and c are constants. The signal is passed through a band-pass filter which rejects DC and the sinusoids of frequencies omega m, 2 omega m and 2 omega c and retains the frequencies omega c minus omega m and omega c plus omega m. The output of the band-pass filter therefore is an AM wave. The modulated signal cannot be transmitted at low power. The modulator is to be followed by a power amplifier which provides the necessary power, and then the modulated signal is fed to an antenna of appropriate size for radiation. Detection of amplitude modulated wave. Detection is the process of recovering the modulating signal from the modulated carrier wave. The transmitted message gets attenuated in propagating through the channel. The receiving antenna is therefore to be followed by an amplifier and a detector. The carrier frequency is usually changed to a lower frequency called an intermediate frequency. Then the detected signal is required to be amplified. The modulated signal is passed through a rectifier. The envelope of the signal is the message signal, and then the signal is passed through an envelope detector. Did you know? Encoder converts an electric signal into code before it is transmitted. This provides better security. A duplex communication system is a system composed of two connected devices which can communicate with one another in both directions. In 1947, Bell Labs was the first to propose a cellular radio telephone network. In 1994, American government releases control of Internet and WWW is born, making communication at light speed. Summary. Let us summarize what we have learned. Communication means sending of message from one place and receiving it at the other place through some mean. Transmission channel is the medium that carries the message in the form of a suitable signal from one place to another. The information converted into electrical or optical form, whichever is suitable for transmission, is called a signal. Bandwidth is a range of frequencies required to convey the information of speech. A signal with zero bandwidth has zero information. Sky waves radiated by antenna at large angles travel upward and then reach the receiving antenna after suffering reflection from ionosphere. The superposition of information signal on high-frequency radio wave is called the modulation. The bandwidth required for amplitude modulation is twice the frequency of the modulating signal. Detection is the process of recovering the modulating signal from the modulated carrier wave.